Good morning. It's still morning for a few more minutes. Oh my gosh, this has been such an amazing meeting. I'm so honored to be here. So inspiring to hear all of these thoughtful and bright scientists discussing all these issues. So I counted up last night because I was curious. I've explored and documented solid waste management in 27 countries. So as a interesting thought, I went into my Google Photos and I Googled each one of our countries, the 3 that are represented here, and posted the first photo that came up. One of them I took last night because I'm constantly taking photos, but I'll let you see if you can guess which country is which, and I'll tell you at the end if you don't know. Okay, so context. What did we mean by that when they introduced me? So I'm going to talk a little bit about the work that I've done sort of characterizing this issue from a big picture perspective. So why are we even focusing on plastic right now? Well, we did some work, a materials flow analysis globally to look at that. This was published in 2017, and plastic is a new material, relatively new material compared to others. It's so useful. We use it in so many applications. So even just starting production in 2050, you saw that annual increase. Well, cumulatively, we have produced 8.3 billion metric tons of plastic by 2017. Because about 40% of that is used in single-use items and packaging, that means that 6.4 billion metric tons had already become waste. So what had we done with that waste? Well, we know we try to recycle as much as possible, but really only 9% on a global average of that plastic has been recycled. We also know that recycling pretty much only delays, but does not eliminate disposal. Traditional mechanical recycling, we know that Brett has a great paper here talking about chemical recycling. And 12% of it had been incinerated, which at this point is really how it does disappear from the planet as far as we know again. So that means almost 80%, 79% had ended up either in our landfills or in our environment. And all of these numbers are projected to grow. Of course, they're cumulative, but that rapid production and use is a business as usual. So hard numbers to imagine. We tried to convert those a little bit, the 8.3 billion, but I still can't imagine 80 million blue whales. Anyway. So we heard a bit about some of the sources. That 80% number, take it with a grain of salt. We've not calculated all of the sources yet. So that 80% is based upon the fact that 83% of our watersheds in the world drain to the ocean. But we do know that there is multitude of sources. So you've heard a lot about some of the microplastics, so our wastewater systems, industrial production of plastic and pellets. What I focus on and the rest of the talk is mostly focusing on our municipal waste, the trash that you and I generate every day. But we do have actually quite a few marine sources, and those include derelict fishing gear, aquaculture has become big, and those numbers have not been quantified, and I think folks that I know, the scientists that are working on that right now, those numbers may be more significant than we realize. So let me talk about the 2015 research. Focusing on the source of the waste that you and I produce every day. What we did is, so what had been happening, right, is they were finding plastic all in the environment, and we were able to sort of back up in this working group at NCs, so UC Santa Barbara, researchers from all over the world. We sort of asked the question, how much is going in? So to quantify this, we looked at 192 countries around the world that have a coastline. We took a 50-kilometer buffer of that coastline and looked at the population density. We looked at the per person waste generation rate, how much of that was plastic, and then how much of that was mismanaged. Mismanaged waste is made up of 2 components. One is inadequately managed waste, and for that we mean not managed in a formal infrastructure, and the other was litter. Those 2 quantified the mismanaged plastic waste within that close proximity to the coastline, and then we had 3 scenarios, with the mid scenario being 8 million metric tons of plastic entering the ocean in 2010. So what does that look like? Well, if you can imagine all of us standing hand to hand, covering the coastlines of the world, each one in front of us would have 5 grocery-sized bags filled with plastic. That's for every foot of coastline in the world, and that's what's going in, or what we estimate to be going in annually. Another important column on this graph is this small one floating on the ocean. So you heard about exploring the plastic floating on the ocean, but really what we think is there, based upon the readings that we have so far, is about 3% of what we think is going in annually, and this is a standing stock. So there's not actually a lot of mass floating at the surface. I don't always put this slide in because it definitely takes some explaining, but conversations here have really led me. I wanted to put this in because if you've heard about pointing fingers about this topic, this has not come from me. The messaging in terms of having the data per country was very much about being transparent on our methods and how we did this, and then looking at influencing factors. So this was snapshot in time. 20 years ago, this map would have looked different. The US waste management system was not as developed as it was today. And so these influencing factors were middle income countries, rapidly developing economies, high increasing consumerism, and infrastructure that was just lagging behind. So understanding those influencing factors mean we can get in front of them in the future. So remember the graph I showed you with the small column in the ocean? You've heard about some of the sinks of where the plastic can go. Some of it does get spit back out. So I was standing in the Canary Islands, and every wave washing up on the shore was a confetti full of plastic. Obviously, we know some of it goes into the biota. We do think, or there are scientists who have hypothesized about most of it sinking. There is sort of another set of folks that really think a lot of it is being spit out on our coastlines and buried. But we know it's ending up in sea ice, in places that basically we haven't been yet. When we get there, we see plastic. Rivers are important conduits of getting the plastic that's on the land to the ocean, and then our rivers and our lakes and our environment itself is contaminated with the material. I want to put this slide up, though, because looking at the science of rivers, there have been two sort of major papers quantifying that. And you can see there's pretty high variability of these estimates. And I think the second paper, guess which one got more press? The second paper, right? Because it was 90% from 10 rivers. But look at the error in that. It could be as low as a fraction of a million metric tons, or it could be half of that 8 million that we estimate. So there's a huge error range there. So just a lesson I'm sure we all do is actually go to the paper itself to read instead of the headlines in the news. So that's sort of the general context. I want to talk now sort of about thinking about solutions. And I don't even really like that word solution because I think these issues are problems that we continue to work on and iterate and figure out how to address. But this framework was developed as a part of a testimony I gave to our US Congress. But it's a nice way to sort of think about the whole value chain of plastic, and even back to that column chart. There's the ocean. If we want zero input of plastic into the ocean, it sort of opens up all these opportunities here for these interventions to decrease that quantity. So the first is, can we reduce demand? This is what we need to worry about for us in the US. We produce 2 to 3 times as much waste per person as many people in other places in the world, including Japan. So I think for us, we really need to look at this. There's not people around the world who have, and I put luxury, access to clean water, access to ways that they can use reusable items to reduce the waste that they're generating. So I think it's important for those of us who can, that we do, and also communicating to others. So if you do this, but taken collectively is how these small changes make a difference. And also, if you're trying to do these things and the system isn't letting you, it's very hard for whatever reason, you can look at how does the system need to change, so these choices are easier. Then I think this is sort of a thought experiment in terms of what we've seen in the past, and we correlated in our research, is that economic growth is coupled with waste generation rates. So when we talk about waste generation, that grows with economic growth. Can those be decoupled? Can we meet people's needs, increase livelihood, and not produce waste? So these are just a couple of examples, not endorsements of anything, but thinking about using technology and sort of our current systems, but going back to reusable items. So that's a new company where you can actually get products in reusable containers and ship them back in a mail order setting. RFID embedded cups and to-go-ware where you can have those associated with you, bring those back, get refills, etc. Dishwashing services, so they're not robots, but you can rent dishes and get them washed so that if you don't have kitchen space, which a lot of to-go places and restaurants don't anymore, you can still do that. But we're not probably going to get rid of all packaging. So thinking about when we do have packaging, designing it for end of life. This has been a component that's really been ignored in the waste field. Just everything that comes at us we have to deal with. So design standards, if things have value, if we don't use toxic components, if we use more homogenized materials, it can be recycled and kept to its highest value. And then I think we're going to look at different materials. So maybe going back to traditional materials or the development of new polymers. I'm sure in the discussion we'll have time to dive into the difference between compostable and biodegradable. But this is an institute at the University of Georgia my colleague runs, and he's mostly working on PHA, which is a biodegradable polymer. Acts like plastic, but when it gets wet and exposed to microbes, it actually does biodegrade. And then sort of moving down that chain, looking at waste management, so global waste management infrastructure. This is the focus of my work really as an environmental engineer. But I've come up with some very general terms for this, and that's because although we have similarities, it looks very different around the world. So we want to collect, capture, and contain our waste. But context and culture are very important. So I teach something called context-sensitive design when we're talking about working within systems. And I want to show a few pictures. I struggle. I have lots of pictures from around the world on what to show, but I think these two photos kind of really illustrate some of the extent of this problem on land, but also when we have what sort of ends up on the ground, these low-value materials. So you see mostly film plastics on your left and a lot of expanded polystyrene boxes on your right, and oftentimes in waterways, because waterways are how the waste can get out of the environment. Also, before we had plastics within the waste stream, there was a lot of organics in it. So people in dump sites around the world allow animals, or actually charge for animals to graze still, where you have a lot of organic material. And of course, we have millions of people at the front lines of this issue working in an environment that compromises their health, their safety, and yet it's an entire economic system that, as I said, millions of people participate in. So that was collecting waste pickers at a dump site. This is a recycling village where people are actually working on bales that had been exported to this country. So this is another paper that we published last year. So this sort of came to be for a few reasons. In the US, we were moved to single stream recycling. It makes it very easy for you. You get to put all your recyclables into one bin. We design facilities to separate them out, but the commodities that come out are not that clean. They need a secondary sort. Also, all of the variability in the plastics make it hard to separate out anyway, so the secondary sort was happening mostly in China. So we were exporting over half our recyclables, and actually Japan, Germany, and the US were some of the top 3 exporters of plastic specifically to China. That paper was done in 2017 or 2018. And so I wanted to show now what's happening in China. So what happened at the end of 2017 is China put in what basically became an import ban because the restrictions were so high. And so that has sort of left a lot of us reeling with what do we do? And it's been great because we've had to reflect on why are we making so much packaging that is so hard to recycle. China, I just spent a week there, is developing its own domestic infrastructure now. So this is an amazing facility where they've taken folks who've been sort of informally working in recycling, allowed them to collect waste in an on-demand app like an Uber for waste. They have amazing machine learning algorithm behind this to predict where to go, and then they're separating out the materials for recycling. In Shanghai, they're now doing source separation, which they had never been doing before. It's the first city within China to do that. So moving down, we've got a last chance capture. Okay. What does that mean I have left? 5 minutes? 5 minutes? Okay. So last chance capture. So you can engineer devices that capture plastic floating. This is Mr. Trash Wheel. He lives in the Baltimore Harbor. He's on Twitter. Amazing. So what this does is capture it, puts it into the dumpster, and that is incinerated for energy. We can also use our two hands. So basically, about a week and a half ago was the International Coastal Cleanup, World Cleanup Day. Folks do capture this material before it gets into the ocean, but what's been important for me is to collect data. So in 2011, we developed this mobile app funded by NOAA. It's called Marine Debris Tracker, and all over the world, people are reporting the litter that they're cleaning up and seeing, and we also use it for data collection. So it's for scientists, citizen scientists, and anybody opportunistically collecting data. In the discussion can talk more about how we can use that data, but talking about collective effort, you can imagine if we have one person making one choice, but lots of people doing that, that's amazing, and this is the first year of data collection. If we have all of us making choices over time, that makes a big difference. So this is just sort of illustrated in terms of this time capture of the data reports that we're getting from Marine Debris Tracker. These aren't individual items necessarily, they could be a group of items, but these are the GPS coordinates that had been reported over time. At some point you'll see when I crossed the ocean, which was in 2014, crossed the Atlantic Ocean collecting data in a 72-foot sailboat with 13 other women. We were also promoting women in underrepresented disciplines like STEM as well. So this has now actually gotten much more international, and we used it for data collection on an expedition that I'll refer to in just a moment. But I'm going to skip to global initiatives. So this issue has risen very quickly up into high-level government discussions. So I participated in G7 and G20 meetings, led a lot in Germany, where declarations were made for both of those, and now the G20 is housed here in Japan this year. Folks like the World Bank, McKinsey, and the World Economic Forum are working on this issue. Lots of big NGOs, National Geographic, Ocean Conservancy, Conservation International, Ellen MacArthur Foundation, UN, and I think probably the biggest thing right now is that a global treaty is being discussed related to this issue. So it has very quickly risen to the top with data that we've sort of produced, but I think we also have needs for more data, I think, in terms of informing these policy initiatives that are sort of quickly happening. Investment strategies around this, prizes about initiatives to reduce this. Something that is now sort of on the radar of scientists and what they're working on is if we have a business as usual of plastic pollution, what are these interventions and what kind of reduction is happening? I'm not leading, I'm just a part of one of these working groups out of SYSINC, which is an NSF-funded center in Maryland, but Pew and Systemic and a few others are working on similar types of work. I actually got small for my big research. I went back to the community level because on all these travels, I would have discussions and the community folks I'd be talking to would say, okay, great, now you made us aware, what should we do? And I would say, you know your community, but here's what I sort of see, observe, and so turning that sort of into a sort of systematic data collection protocol to be able to collect data in collaboration with the community so that they can be empowered with that data to figure out how to move forward. So we look sort of at the materials flow, but it's much more than that. We're sort of measuring these outside influences, and it's a mixed method, a lot of qualitative data besides the quantitative materials flow. Very important to do this in collaboration with folks. They provide so much knowledge and data on what you see on the ground and what it is and where it came from. So you don't just end up with this kind of data, which is important, how many items you see, what are the top items, but really the insight from the community, oh, here's what's going on, why we're seeing this density, this high density of these specific items. So we're using a lot of geographic information systems and correlating what we find on the ground with sources that we're mapping as well and discussing those with the community. Quickly, we just finished an expedition with National Geographic and did this protocol as well as sampling floating plastic, sediment, air, interfacing in social sciences and socioeconomic studies with small villages and communities, flying drone, putting some sensors in, trying to really understand the flux of plastic from land to the sea, that empirical data that really has been missing. So that was in 10 sites along the Ganges River, 3 in Bangladesh, 3 in India, again in collaboration with in-country partners in both of those countries and community volunteers. So I just want to say to all the millions of people really working at the front lines of this issue on waste around the world, thank you to them, thank you to my partners, and thank you.